Hello, Strange Loop. How are you all doing today? My name is Tilde. That's pronounced like Tilda Swinton or like the little squiggle on your keyboard. I'm a developer evangelist at Twilio, and I'm here today to talk to you about using declarative APIs in an imperative world. What I'm going to cover is what is the difference between declarative and imperative programming paradigms, why you'd want or need to integrate the two. Before I was a developer evangelist at Twilio, I was an application engineer working on the Atom editor. So then I'll send you into some nitty-gritty details about how we integrated some imperative Atom APIs with React, a declarative framework. And then I'll tie the whole thing into the context of the bigger picture with what we can use from the history of language and framework trends to make the future better. So, what even is declarative programming? Declarative programming is done with declarations rather than statements. What? That definition tells you exactly nothing, almost nothing. How about declarative programming expresses the logic of a computation without describing its control flow? Still not really sold on that. I came across a blog post from a guy named Tyler McGinnis that had the best definition that I've seen, which is that declarative programming is about what you do, not how you do it. So I'm going to ask you a question, and I'd like you to think of both an imperative and a declarative response. So how do you get to the St. Louis Arch from here? The imperative response would be, head east on Market Street towards South 14th Street, then turn right on South Tucker Boulevard. Because turn-by-turn driving directions are imperative AF. Now, declaratively, you would merely specify the address by putting it into, pretend this is like a ride-sharing kind of interface. Because declarative frameworks abstract away the turn-by-turn directions, and then you just get where you're going. But that layer of abstraction is always there, because at some level, computers are still pretty stupid, and they need us to give them pretty clear and exact directions on what to do. So declarativeness is just another layer of abstraction. The good news is you're probably already using some declarative paradigms without even knowing about it. Can anybody tell me one? Anybody in the front, because I can't hear you in the back. Yeah? SQL, absolutely. CSS, you're absolutely right. They're even called declarations. React, yeah, we'll get to that in a second. HTML is declarative, and pure functional languages such as Haskell can also be considered declarative, and regular expressions. One big advantage of declarative UI programming in particular is that it helps with a whole class of bugs caused by state management. So I first started doing JavaScript UI development back in 2013 at Pinterest, and my first real assignment was rewriting the Digital Millennium Copyright Act forms. Funsies, not funsies. But let me tell you what, I learned a ton about state management bugs and requirements gathering from lawyers. But for today, let's talk about a simpler interface. So this is it's like a list of people, and you can add and remove them. This exists in reality on every website ever that's please invite all your friends. I forked some code for this originally from a code penned by Alberto Gimeno. Let's take a look at the implementation. So it takes 13 lines of code. 13 lines of code to sync the state with the UI when you add a new thing to the list. Now, granted, we're using vanilla DOM APIs here, but using jQuery wouldn't even help you all that much. But worse than the verbosity is that it's pretty darn fragile. If you have two people with the same name and you're not using unique data IDs, you're going to have a bad time. And this is just demo code. So if you think about the additional complexity of like a production application, it gets even worse. So let's look at the same implementation in React, a declarative UI framework. In React, you have an explicit object representing the state so that the code to add and remove things becomes much easier to read and to reason about. It's more concise and less error-prone. So there's one more React concept you need to know to understand this talk, which is props. So in React, we have a component hierarchy, where each component has its own state, and it keeps track of that state. But then parent components can also pass down data to child components in the form of props. And then the child components can then re-render themselves based on those props. Now, note that this only works one way. Children cannot pass data directly back up to their parents. So React is far from being the only declarative framework. Angular and Vue are also great. I'm not into framework wars. I'm just picking React because it's the one that I'm the most familiar with. Engineering, just like life, is all about making trade-offs. And in order to do a good job making trade-offs, we need to know what the good parts and the bad parts are. So what are the bad parts about declarative UI programming? Well, I mentioned earlier that declarativeness is another layer of abstraction, and what do we know about abstractions? Abstractions are decadent, and we're just living these bougie lives where we don't have to care about the size of pointers anymore. And I'm kidding, but I did hear someone over here say that abstractions leak, and you are absolutely correct. If you want to do something that a framework doesn't have an affordance for, you are kind of hosed. Another problem is that declarativeness is frequently accomplished via a domain-specific language. Domain-specific languages are another language to keep track of on your cognitive stack. So React, you write your templates in JSX, which, in my opinion, it looks just enough like HTML to be confusing to beginners. And not beginners. Like, raise your hand if you've been tripped up by the capitalization of class name. Because, like, yeah, see, I still do that. So now that you understand a little bit more about the difference between declarative and imperative APIs, let's talk about how to integrate the two. So first, what kind of imperative APIs exist that you might want to integrate with? Well, there's video. Because I work at Twilio now, I am contractually obligated to mention telephony APIs. There's mapping and GIS applications. There's animation libraries like WebGL and 3JS. And there are the APIs of the Atom editor. So Atom, for those of you who might not have heard of it, is a free open source editor built on web technologies like HTML, CSS, and JavaScript. So it's a standalone desktop application, but it's built on top of a browser, which is pretty cool. Now, if you're integrating with imperative APIs that your team owns, which I was, you kind of got to ask yourself some hard questions, like, should we just rewrite this imperative API to be more declarative? In our case, we decided against it, because Atom has a huge ecosystem of community packages, which is one thing that makes it really great. And if we rewrite the APIs, we either need to force package authors to upgrade, or we need to maintain both versions. Plus, honestly, it would have been a lot of work. We didn't want to do it. You might ask, why are the Atom APIs so darn imperative? Well, Atom was originally written in 2013, before declarative programming got as wildly popular as it is now. Speaking of packages, in Atom, everything is a package. You get a package, and you get a package. Everybody gets a package. The package that I more specifically worked on was the Git and GitHub integration that's built into the editor, so we're going to be diving into that. When integrating React into an existing application, how do you choose your entry point? Well, there's a couple of options. Say you had like a fully imperative application, and you wanted to start sprinkling React into it. In that case, you could start at the leaf nodes and integrate small, reusable components, such as buttons, from the bottom up. But we Atom allows you to inject DOM trees into arbitrary places. We were starting from scratch, and we knew that we wanted our whole tree to be React. So we took a top-down approach, something like this. So we got our root components, and then some children all up in there. And then for each imperative API that we cared about, we had a wrapper component that was responsible for maintaining the declarative imperative boundary. So first, I'm going to show you the Atom text editor, which maps onto the text editor API. The text editor API controls things like any state that's applied to a text editor. Where are your cursors? Do you have any blocks of code folded currently? Do you have soft wrapping enabled? That kind of thing. I'm showing you simplified versions of this code for sake of readability and time. So we use Atom's built-in library for PubSub, which is composite disposable. How many of you have used a PubSub library before? Cool. Well, for those who haven't, for PubSub, it's like you subscribe to events, and then you do stuff or fire a callback when those things happen. So that did change cursor position prop is passed down from the parent component so that the parent can force update and re-render the whole tree when a cursor position changes. Now, I'll be the first person to admit that this is not the most declarative possible approach that I could think of. It would be more declarative to actually lift the state and the position of the cursor into the parent component and let it decide to re-render itself. But with the way that the Atom API was, that was kind of clunky because you need to pull for updates. You can have multiple cursors, so things get kind of messy. And we decided that we didn't need to keep track of state that we didn't actually need, just to meet some arbitrary standard of declarativeness. So your code doesn't have to be perfectly declarative to work. Example number 2, the panel component. It wraps the Atom panel API. So a panel is a container on the edges of the editor window, like this pull request review panel that was shipped a couple of months ago. Here we take advantage of React DOM create portal to start a new component tree somewhere else in the DOM, away from our main tree. And it knows how to render any children it needs to render. Here we're using should component update as a performance optimization. When should component update is implemented, your component isn't going to update every time you get new props. So in this example, we only want to update a panel if it's being hidden or shown. We don't care about all those other props. So don't use component will receive props for this kind of optimization. It is a deprecated method, and if you try to use it, you're going to have a bad time. Another important thing is to make sure that components clean up after themselves. So when a component's unmounted, you need to dispose of any listeners and then call the API to actually remove the component from the DOM. So one problem that was particularly gnarly to solve was focus management. So part of my motivation for doing this talk was that I didn't understand the focus management code very well, and I wanted an excuse to dive in and really learn it. The solution involved refs. Refs are React's dirty little secret, and they allow you to reach in and manipulate the DOM nodes directly, imperative style. React's documentation says, are you sure you need refs, dog? You probably don't need refs. But the use cases that it listed were integrating with imperative APIs or doing focus management. Since we were doing both, we figured that we were covered. So you create a ref by calling, surprise, create ref. And then you pass that ref to a DOM element in your JSX. Then to actually focus it, you call ref.current.focus. But we had a problem. React doesn't guarantee that refs are available until the component is finished mounting. But a component doesn't finish mounting until all of its children are mounted. But what about when a child needs to consume a DOM node from its parent? So the solution we came up with is called ref holders. Ref holders allow us to defer operations until the DOM node actually exists. So in the parent, we set the ref setter on our div and then pass the ref holder to the child component. In the child component, we use this observe method to defer actions until the DOM node actually exists. So a ref holder is an example of what's known as a maybe monad pattern. If you're giving a talk at a functional programming conference, which this kind of sort of is, then you're required by law to explain monads. Don't hate me, I didn't make the rules. But they're not as hard as you've been led to believe. They're basically like a tortilla or a burrito. They're a wrapper for a thing. So you use functions to wrap values in monads. And then you can even nest them inside of one another, kind of like some sort of Taco Bell nightmare burrito inception thing. Now, I used to be so confused by the whole concept of functional programming, because all I heard was that side effects are bad and they should be avoided. But then I learned that that's not necessarily the whole truth. Side effects there's some really important computery things, like reading from disk, that are entirely side effects. So monads are just a way of signaling, hey, there might be side effects here, so you can isolate them to certain parts of the code base so they're easier to read and reason about. So maybe monad is a special kind of monad, and it's a wrapper for values that might be null. So you can gracefully avoid a null pointer exception, or cannot destructure undefined, or whatever that looks like in your language of choice. But this is where the tortilla metaphor kind of falls apart, because an empty burrito is not going to protect you from anything, even the emptiness inside your own soul. So I came up with another metaphor to explain maybe monads, a social metaphor, if you will. So I had a big crush on this girl for a while, and then eventually I asked her out. And I said, hey, I'd really like to take you on a date, but if you don't want to, that's totally OK. I will never bring this up again. Saying no can be really hard, and with good reason. Like, some people really don't handle rejection well, and it can even be dangerous. So I don't blame anybody for being afraid of saying no. So I wrapped my request for a date in a maybe monad to signal that if her desire to date me was null, I would handle that gracefully. And so I was like, hey, call me maybe monad. And she said yes. Anyway, another more JavaScript-y way of explaining monads is that a promise is a kind of monad, because a promise lets us write code without worrying about whether asynchronous data has arrived or not. Similarly, a maybe monad lets us write code without worrying about whether our data is null or not. And I'm not using the mathematically precise definition of what a monad is, so I don't think this definition that I gave you is going to be useful for you actually trying to learn Haskell or something. My point is to try to make the terminology more accessible to people, and then when it's time to learn more, then you can. So don't at me about category theory or functors. Cool. Anyway, focus. Atom's focus uses commands, or to focus things in Atom, you use commands to move back and forth between elements, so that you can move the focus part, you can move focus around in your editor without using a mouse, which is important for both power users and folks who can't use a mouse for accessibility reasons. So let's talk about the commands API. Atom's commands registry lets you associate listener functions with commands in a context-sensitive way using CSS selectors, because maybe you want a command to mean something different depending on what part of the editor is currently focused. So the command registry is essentially global because we're using a style of event handling known as event delegation, which is popularized by jQuery. As the event bubbles upward through the DOM, all registered event listeners with matching selectors are invoked in order of specificity, just like the CSS cascade. So we have this commands React component, which wraps the command registry API and allows you to add new commands. So annoyingly, because it's essentially global because of the event delegation pattern, and because React has that one-way data binding that I talked about earlier, where all your data can only be passed down, we have to pass down the command registry from the root component through our very deep tree to anywhere that wants to be able to focus elements. In fact, this is really a problem throughout our entire code base, at least up until the point where I left, where a lot of the Atom APIs just want a ton of props that need to be passed all the way through. It's super annoying, and we, at the time that I left, hadn't figured out a good solution for it. Like, we would tend to use the spread operator on our props, but in my opinion, that's a code smell, because the whole point of props is for human readability. It's so that the people working on your code with you can look at it and understand what the dependencies coming in from above look like. So some solutions that we had for fixing this were to use the context API that was introduced in React 16.3 and maybe some hooks to make it a little less repetitive. So we move focus around by registering atom commands. In our root React component, which is the code that I'm showing you here, we have these ref holders, which can be passed to child components to move the focus around. And then we also have an event handler that keeps track of the last focus position. Every time focus changes to an element that's a descendant of this component, the event handler fires and sets this .lastFocus. And then we pass the root ref down to any child components that have focusable elements. These child components must implement a method called rememberFocus to inspect the event target and know where to restore the focus to. And then we imperatively call focus on the right element. Another annoying thing about this is that when you open up the developer console, the focus changes to the console. So we had to put in some logging tracer snippets that were really useful to our open source collaborators working on the project with us. So the last imperative API I'm going to talk about is Git. One important use case for the Git integration is that we want you to be able to use Git from the editor and switch seamlessly to Git on the command line and have everything be in the same state. In order to do that, the editor actually shells out to the command line and runs Git commands directly. So that meant that we needed to encapsulate the Git API. It kind of looks like this. So we have these model objects, which are plain JavaScript classes that represent Git entities, such as repositories. And then we have some middle components. Then we have a model observer, which gives us a consistent imperative API for fetching data from the models. The models emit events, and the model observer does stuff in response to those events. Observe model, on the other hand, is a React component that gives us some state where our data lives, as well as letting us define functions to fetch that data. Now, I'll be the first to admit that model observer and observe model is a super confusing naming scheme, or at least I found it to be so. But I don't know, I don't think I could have come up with anything better had I been the person to name this, because naming things is hard. When we use the observe model component, we specify exactly the data that we want from the repository model in our fetch data function. And then observe model takes a render prop, so we can say, hey, here's how to render the error state. Here's how to render the loading state, et cetera, et cetera. So now that I've talked about some imperative declarative APIs that I worked on and how to integrate the two, let's put that knowledge in the context of the bigger picture. So if declarative UI development is really so much better, then why the heck were we ever doing anything any other way? I thought about it, and I came up with 3 reasons. Reason number 1, the web did not used to be so darn complex. I'm going to pick on Amazon for a minute, but look at this page. Just look at all the buttons and widgets and what's-its. We did not used to have full-on applications sitting inside of our browser. Things have changed so much. And just like anything else, there's positive and negative side effects to this complexity. But also, state management bugs become a lot more of a problem the more complex your state is. So we need declarative UI frameworks now more than we ever did before. In fact, I'd even say that we have come full circle because we are building desktop applications like Atom, like Slack, like Visual Studio Code on the Electron platform. So we're building desktop applications on top of browsers, which is really cool. It's wild. Reason number 2, programming is fashion, in the sense that programming is discourse. It's an ongoing conversation. Everything is a reaction to the thing that came before it. First, we had vanilla JavaScript, and then we had jQuery that made it easier to do things like make AJAX calls, add and remove class names, things like that. And then came React and the rest of the declarative UI frameworks that were a reaction to jQuery. Reason number 3, I was asking the wrong question. If you expand the definition of we, then we actually were using declarative UI frameworks before. So Qt, Qt, I don't know. I didn't get good consensus on how to pronounce this, so I'm just going to go with Qt. But it's a desktop framework that's been around since 1995. It powers things like Adobe products. Qt has been declarative since 2000. React was open sourced in 2013. Now again, there's a bunch of other factors that I've talked about, like the rise in complexity, that made us not need declarative UI frameworks as much until now. But I don't know, 13 years still seems like a really long gap, and we could have picked up on this innovation a little faster. Some questions to reflect on. What else can web UI developers learn from desktop UI developers, insofar as the groups are different now? What can we learn from back-end developers, from functional programmers? What lessons can we draw from the history of computing so we can stop making the same mistakes and reinventing wheels? I've got to say, it would be a lot easier to answer these questions if we weren't pushing older folks out of the tech industry at such a high rate. Ageism is real. It's real, and we need to talk about it. We're going to talk about it, in fact. Ageism is particularly real in Silicon Valley. I want you to do a thought experiment with me. So Mark Zuckerberg famously said, young people are just smarter. I know, right? That's gross. But think about, replace young people with men in that statement. How does that change your feelings about that statement? How would that statement maybe go over differently in the public arena? And I know, the irony of dragging Zuck in the same talk where I'm praising React is not lost on me. So Silicon Valley's 150 biggest tech companies have had more accusations of age bias over the past 10 years than racial and gender bias. And speaking of racial and gender bias compounds. It's multiplicative, not additive. Older workers who belong to other under-indexed communities are more likely to face discrimination. According to Stack Overflow's 2019 survey, 75% of professional developers are under age 35. That's an absurd proportion. In order to fix things, we need to get to the root. So, what is the root cause of ageist thinking? I have a few ideas. So ageism is a problem that's going to impact us all eventually, right? If we live long enough, we're all going to get older. And I have a sneaking suspicion that one of the roots of ageism is fear. It's fear of our bodies wearing out. Well, I have some news for you, and you're not going to like it, but you need to face it. You're going to die someday, and you need to make peace with that reality. I mean, Alphabet even started an entire company, Calico, to solve the problem of death. I mean, haven't anybody ever seen an episode of Black Mirror? Even if it was possible to solve death, I guarantee it would not go as well as you think it would. Come on, Silicon Valley, grow up. So other than coming to terms with the inevitability of our own deaths so we can combat ageism inside ourselves, what can we do? Well, for starters, let's just rethink the whole concept of aging, because it's a relatively recent concept. So according to historians Carol Haber and Brian Grattan, 200 years ago, we didn't think of older people as a distinct population, but a bunch of pseudoscience changed that. So in the first half of the 19th century, doctors believed that people were born with a certain amount of vital energy, and that was a substance that you would gradually deplete, and that when depleting it would cause you to age and then eventually die. And obviously, that's bullshit, right? It's been debunked, but at the same time, it changed how we think about things. Childhood is also a relatively recent invention. We used to just kind of think of and treat children as small adults. And not like I'm saying we should go back to that. Child labor laws are a good thing. And I'm not saying that ignoring ageism is going to make it go away. It's definitely not. Just the same as ignoring racism and sexism doesn't make it go away. It's Socially constructed things are still real. Money is socially constructed, but we still have to deal with it. It's just that, okay, this is evidence that we already changed the way we think about aging once. We can change it again in a better direction. But okay, the root problem is always capitalism as you look deep enough. But there's a sick kind of feedback loop where the way that we design and build products for older people reinforces the idea that older people are a problem to be solved. And since technologists are responsible for shaping so many products, shaping the future so much, we need both age diversity and age inclusion on our teams. So how do we get there from here? Well, a lot of the next suggestions are of the rising tide lifting all the boats variety, where anything we can do to help older folks helps people in any marginalized group. So using objective hiring criteria is one way to move that needle. So we started using interview rubrics when I worked at Pinterest, and I was surprised by my own bias, because we all like to think that we're unbiased, but we're not. And it's really easy to have a candidate walk in the door and decide you like them, and then decide that their answers are good enough. But it's harder to do that if you've already decided what good enough looks like before they've even walked in the door and written it down. So Medium actually open sourced some of their hiring rubrics in an article. You should check it out. But I wanted to give you a practical example of what this looks like. So a no might be the candidate can't name any of the most common data structures, whereas a yes might look like the candidate understands space and time complexity, even if they're not calling it big O. Another thing you can do is change your language. Remove phrases like, so easy your grandma could use it from your vocabulary. Now, changing language is super hard. You're going to mess it up. Don't feel bad. Any kind of allyship is a process. It's not a result. So just keep trying, and eventually you'll get better. Speaking of language, you'll want to audit your job postings, because that's another place that bias can creep in. There's a company called Text.io that is using machine learning to help make your job postings attract the most diverse candidate pool that's possible. Caveat, I haven't personally used Text.io, but I've heard good things from the folks who have. Another good thing to do is to ask, because there is no one-size-fits-all solution for inclusion. It's always best to ask people how you can support them. I asked on Twitter, and I got a really insightful response, which is that you should aim for the same emotional presentation and takeaway, especially if you're a supervisor. People notice if you laugh and joke around with other people and not with them. And it makes so much sense, because humor is how we bond, or one way we bond with other people, right? Especially in the workplace. Always use humor to include, to bring people in, not leave people out. And finally, we can stop being so obsessed with shiny new things. I disagree that rewriting your entire code base every couple of years, the way we tend to do it, is healthy. We need to get better at reading code instead of writing it. We need to incentivize maintenance. We need work-life balance. And I don't think these things directly contribute to the lack of age diversity in the workplace, but I think they're symptoms of the same kind of short-term thinking. So let's review what we've covered today and tease out some themes. Declarative UI frameworks are eating the webby world, according to NPM's most recent developer survey. But it's not just about growth. It's about satisfaction. If you've ever built tools for developers, you know that we can be a really tough crowd to please. But overwhelmingly, people love the declarative frameworks. Hopefully, this talk has given you a little more context on why they are the jam. And now you understand some patterns for integrating React with imperative APIs. What I really want to emphasize here is that there's no one-size-fits-all. Fundamentally, the way you choose to communicate across the declarative-imperative boundary depends on the API you're trying to integrate with, because the question is, how do you model the state of your application in a declarative way? And now you have maybe some questions to start asking yourself. In case you want to see any of the code I showed you today in a little more detail, it is all open source, and you can check it out at the repository above. And finally, you've heard a few things you can do to combat ageism within yourself and within our industry. So I'd like you to reflect. What action are you going to take to make things better both for yourself and for our entire industry? It takes a village to make a talk, and credit where credit is due is super personally important to me. I'd like to thank Alberto Gimenez for the declarative and imperative UI code examples I forked, Tyler McGinnis for the blog post on declarative and imperative that shaped my understanding of the definition of it, Evelyn Masso for the call me maybe monad metaphor, Katrina Oichako, Joe Furman, and Ashley Christian for giving me feedback on the beta version of this talk. Thank you to the wonderful organizers of Strange Loop for all the hard work you put into making this event. And finally, thank you.